Next is Cloud Chaser, and after that, running into the 90s.
Activate Cloud Chaser. Alexa, activate Cloud Chaser.
Welcome, Cloud Chaser.
Go to Bottle.
Tracking bottle. Chaser running.
Welcome to Cloud Chaser, a robotic platform that receives voice commands and tracks and follows objects. Cloud Chaser was built by 3D printing a custom chassis and attaching 4 continuous motion servos. We also attached an Amazon Echo Dot and a Raspberry Pi. What we're doing is we're streaming a video up to the cloud. Up to the cloud, we're using a YOLO convolutional neural network algorithm to identify objects in the scene and identify bounding boxes around the objects. We're using the bounding boxes then to identify what object we're going to track and to determine how to track it. We're then making a decision as to what the robot does next, sending down the command, and the robot then receives the command and executes the next operation.
So Cloud Chaser is really only an MVP of a broad service that we are thinking about building. It is enabling low computing power Internet of Things, for example, a Raspberry Pi, to offload its computing power to do some higher level vision technology, vision tasks, for example, computer vision, and so it can run higher level algorithms to achieve what we can say intelligence.
Right, so the robot is really a means to an end here. The real, the platform is that so everything that is being done here is not on the Raspberry Pi. It is on the cloud, and the Raspberry Pi, all it's doing is receiving data like left, forward, right. So that means that any sort of microcontroller or other low power computing device that can move wheels and stream to Wi-Fi can run Cloud Chaser. So we want to get into a demo here?
Demo? Okay.
Yeah.
Can I get the screen?
Yep. So we can also switch targets mid-go Cloud Chaser. And we also have the live screen of the bounding boxes.
So 1 second, let me mirror the
Yeah.
Okay.
We have-
So can everybody see?
Yeah, while he's setting that up, I'll talk about. So Cloud Chaser was the Chase, the robot. You can see where the name comes from. Was built with a custom 3D printed chassis, and then also we custom 3D printed the mount, and we screwed all of the wheels in, and we're actually pretty proud of the design because it's like decently sturdy. It's better than any robot I've ever built for anything else. So.
Can I get back to the? Yeah.
One of the biggest challenges for Cloud Chaser was the latency for the camera. As you'll see, if the camera gets up on the live stream, we wanted it to be as close to real time as possible because the data from the camera is what determines where we go. Because we're not doing any of the actual tracking computation on the Pi, all of it's what the Pi sees is what the cloud sees. So if there's any latency, that would show up big time in our tracking. So what we ended up doing was we had our driving code really low priority, and then the camera highest possible priority. So all of the time is spent streaming the camera data, and almost no time is spent driving. Okay, cool. So here's the demo. So
Alexa, activate Cloud Chaser. Go to bottle.
So as you can see, if you look on the screen, it's identifying the people in the scene, and it's identifying bottle, and it's driving towards it. Now you can change the target.
Go to person.
And it should turn towards the person.
So you can see the bounding box. It's recognizing object. Let's
Yeah.
to a laptop maybe.
Well, we don't have any more time, so we have to take questions now.
Oh.
Yeah. So.
Can you talk more about what the biggest challenge was doing this?
Yeah, sure. So there are multiple components that needs to talk to each other. So we have Alexa, which lives on the Amazon cloud. We have Raspberry Pi, which is the onboard driving. And then we have the cloud machine, which is higher power, GPU powered, that's running neural networks for the object recognition. So in order to achieve a great frame rate, we have to initialize like 3-way TCP connections. So the cloud has to talk to the Raspberry Pi for controlling, and then the Alexa, which is basically the interface, it needs to initialize a TCP to the cloud, and the Raspberry Pi has to initialize a TCP that stream the video to the cloud. So we have different scripts. So in order to set this up, I have to fire up 3 different scripts, initialize 3 different connections, so they will talk to each other and then achieve this flow.
And this is all to avoid having to do any computation on the Pi, because we want all of the computation to be done on the cloud. So Alexa can't talk to the Pi because that would make the frame rate go down.
Any more questions? All right, thank you.
Hey guys, how's it going? So we've had some deliberation from our top 3 judges. We had a lot of great hacks today, but we've had to narrow it down to 3, and so our top 10 judges will go and narrow it down for you guys.
All right, yeah. So we're going to say 3rd place goes to Scavenge AR.
And 2nd place goes to Modware.
And congratulations to the 1st place winner, Cloud Chaser.
Congrats to all the winners. If you were one of the top 3 winners, please come up on stage afterwards to take pictures with the judges.